rapidly add 50 milliliters of 1 molar sodium hydroxide to 50 milliliters of 1 molar hydrochloric acid in a coffee cup, and the temperature rises from 19.0 degrees Celsius to 25.7 degrees Celsius, calculate the change in enthalpy for the reaction. Enthalpy of a reaction is defined as the heat flow into or out of the surroundings in a system and is measured in kilojoules per mole. We can calculate the enthalpy of the reaction by measuring the Q, or heat of the reaction, divided by the moles of the system. The chemical equation for this reaction is hydrochloric acid combined with sodium hydroxide produces sodium chloride and water. Molarity is expressed in units of moles per liter. The equation we will use to solve this problem is Q equals mc delta T, where Q is the heat flow, m is the mass, C equals the specific heat capacity, and delta T is the change in temperature. We then need to determine the total volume of the surroundings for our equation. We know that we have 50 milliliters of hydrochloric acid and 50 milliliters of sodium hydroxide, which will produce 100 milliliters of solution. We can convert the total volume of solution to grams of solution using stoichiometry. Assuming the densities of the solutions are the same as for water, which is 1.00 grams per milliliter, so 100 milliliters of solution equals 100 grams of solution. The specific heat capacity of water equals 4.184 joules per gram degrees Celsius. The initial temperature is 19 degrees Celsius, and the final temperature is 25.7 degrees Celsius, so delta T equals 6.7 degrees Celsius. Now we just have to input the values in the equation. The mass of solution equals 100 grams, and C of water equals 4.184 joules per gram degree Celsius. The Q of solution plus the Q of the reaction will equal 0. From this, we can calculate that the Q of solution equals the negative Q of the reaction, which equals negative 2,803 joules. Since we are solving for the change in enthalpy of the reaction, we need the number of moles for the system, which is hydrochloric acid, which can be calculated by using its measured volume and known concentration. From the molarities given, the number of moles of hydrochloric acid in a 50 milliliters solution is 0.05 liters times 1 mole per liter, which equals 0.05 moles of hydrochloric acid. In order to find the enthalpy of the reaction, divide the amount of heat of the reaction by the moles of hydrochloric acid. So negative 2,803 joules divided by 0.05 moles of hydrochloric acid equals negative 56,060 joules per mole. To convert to kilojoules per mole, simply move the decimal point 3 places to the left. In conclusion, the change in enthalpy for the reaction equals negative 56.1 kilojoules per mole. In other words, the heat released by 1 mole of hydrochloric acid to the water is 56.1 kilojoules.